advanced in the form that you find it difficult to separate the laws of indices and the laws of logarithms as they are applicable in the topic. For instance, we know that 8 is 2 times 2 times 2. That means 2 exponent 3 is equal to 8. 2 exponent 3 is equal to 8. In logarithms, it means that the log to base 2 of 8 is equal to the index 3. It is better written that log to base 2 of 8 is equal to 3. Likewise, you and I know that 100 is 10 times 10. That means 10 exponent 2 is equal to 100. 10 exponent 2 is equal to 100. In the laws of logarithms, log to base 10 of 100 is equal to this index, which is 2. It is better written as log to base 10 of 100 is equal to 2. With this illustration, you could have understood why I said that indices and logarithms in SS3 is more advanced than the ones you met when you were in junior class. Bearing this in mind, when we go into solving problems proper in this topic, you are going to find this illustration very, very applicable. The first question said we should evaluate log to base 2 of 4. This is the law of logarithms expressed. We are going to join it together with the laws of indices to be able to decode or solve this question. The first thing you do when this question confronts you is this. Select the log to base 2 of 4 be equal to, choose any letter. I'm in love with x. So let it be x. Transform this logarithm terms into its indices equivalents. By doing so, you are going to discover that 2 exponent x will be equal to 4. Remember, when I was illustrating, 2 exponent x is this. That means the log to base 2 of 4 is x. And that's exactly what you have here. If this is the case, try to equalize both sides of the equation. Here you have 2 exponents x. Change 4 to an exponent of 2. You're going to have that 2 exponent x is equal to, you know that 4 is 2 times 2. That means you have 2 exponent 2 being the value of 4. As you have done this, in the left-hand side you have base of 2. Likewise, on the right-hand side you have base of 2. You can cancel the bases and equate the index. That gives you that f is equal to 2. And that is the answer to that question. Question number 2 says we should evaluate log to base 9 of 1 all over 27. The same process, you have to start by saying let the expression log to base 9 of 1 all over 27, let it be represented by any letter. I told you I love x. If this is the case, that means 9 exponent x is equal to the index you have here, 1 all over 27. The first thing you do is change this fraction to an index. The law of indices number 4 told us that 1 all over 27 is something as 27 exponent minus 1. Bring down 9 exponent x. Try to balance both sides of the equation. Here you have 9 exponent x. Change 27 exponent minus 1 into an index of 9. You and I know that 3 times 3 is 9, and 9 times 3 is 27. That means 27 is the same thing as 3 times 3 times 3. Use it to exchange this. You have 3 exponent 3. Now bring minus 1 in a bracket. 3 exponent 3 into minus 1 is something as 27 exponent minus 1. Remember, in the left-hand side of the equation, we have 9 exponent x. You are going to change 9 exponent x also into an index of 3, so that you have both sides of the equation balanced. 9 means 3 times 3. The same thing as saying that 9 is 3 exponent 2. Use 3 exponent 2 to exchange 9. You're going to have that 3 exponent 2. Now bring the exponent of x you already have here into a bracket. Is equal to what you have here, which is 3 exponent 3 into minus 1. Already you have the same basis in both sides. Do away with them. Now equate the index. The index you have is 2 into x. It's now equal to 3 into minus 1. Remove the bracket. 2 times x will give you 2x. It's going to be equal to 3 times minus 1 will give you minus 3. Now you are finding x. You are going to divide both sides of the equation by 2, so as to eliminate 2 from the coefficient of x in the left-hand side of the equation. If you divide 2x by 2, you'll be left with x in the left-hand side of the equation. In the right-hand side, you have minus 3 divided by 2. X is boiling down to 2 divided 3 will give you whatever you have is going to be a minus. Then 2 divided 3 will give you 1. 1 will remain. That 1 will not be divided by the 2 that is divided. When you have done that, you have come to the end of that question. The third question says, evaluate log to base 25 of 0.2. You do that by saying, let the expression log to base 25 of 0.2, let it be x. 25 exponent x will be a 0.2. Thereof, 25 exponent x will be 0.2. Change 0.2 to a fraction so that you will be able to apply the laws of indices. 0.2 is something as 2 divided by 10. In the left-hand side, you have 25 exponent x. Bring this to its lowest term. You're going to have 1 all over 5. In the left-hand side, you have 25 exponent x. Now, change this to an index form. You're going to have, on the left-hand side, 25 exponent x is equal to 1 over 5 in index form means 5 exponent minus 1. That is obeying the fourth law of indices. Now try to balance what you have in the left-hand side with what you have on the right-hand side. What do I mean by that? Already you have base of 5 here. Change 25 to a base of 5. You know that the square root of 25 is 5. That means 5 times 5 is 25. So change this to 5 exponent 2. Now bring into the bracket the already existing exponent of x. It's going to be equal to what you have on the right hand side of the equation, which is 5 exponent minus 1. Now you have established the same base on the left hand side and also on the right hand side. You can do away with the bases and equate the index. The index on the left hand side is 2 into x, while the index on the right hand side is minus 1. Remove this bracket by multiplying 2 and x. It's going to be equal to what you have already existing on the right hand side of the equation. What you are looking for is x. That means you are going to divide both sides of the equation by 2, which is the coefficient of x in the left hand side of the equation. When you divide 2x by 2, you'll be left with x on the left hand side of the equation. On the right hand side, you are going to have minus 1 all over 2. Minus 1 all over 2 is better written as minus 1 all over 2. That means x b minus 1 over 2 solves that equation. Fourth illustrative question says that we should evaluate log to base 1.2 of 1.728. Start by saying let that expression, whatever it is, here we have log to base 1.2 of 1.728. Let it be represented by any letter. Let's use y now. Let it not be as if you do not use x, you will not get to your answer. That means that 1.2 exponent y is something as 1.728. You are going to change the decimal numbers into fractions so that you can transform it into index form. When you are doing that, you are going to find out that 1.2 is something as 12 all over 10. I suppose you know how to change decimal numbers into fractions. This will be exponent y. Don't forget. Is that equal to 1.728? A decimal point means something as 1728 divided by 1000. Now, you have the index of 12 all over 10 in the left-hand side of the equation. Change 1728 all over 1000 into an index of what you have here. How do you do it? Just use a calculator. Begin to multiply 12 by itself until it clicks to 1728. 12 times 12 is equal to 144 times 12 is equal to 1728. That means 12 exponent 3 is 1728. It is very, very likely that 10 exponent 3 will also be 1000. That means the fraction we are going to have, or the expression we are going to have on the right hand side of the equation is going to be, first of all, in the left hand side we have 12 all over 10. Exponent y will now be equal to 12 all over 10 exponent 3. Because 12 times 12 times 12 is 1728. 10 times 10 times 10 is 1000. That was why we now exchange 1728 divided by 1000 into 12 all over 10 exponent 3. You have succeeded in having the same base on the left hand side of the equation as you have on the right hand side. you can cancel the base and equate the index. The index you have left is y is equal to 3. And that has brought you to the end of that question number 4. Now we have come to using those laws I stated earlier in solving practical problems. That was what brought us to evaluation without tables. This table means the 4-figure table that you know. You know that is in junior classes you use the 4-figure table to evaluate logarithms of numbers. But the one I am introducing now is how you can evaluate logarithms of numbers without using tables. So pay attention as we go ahead. Number 1 says that given that log of 2 is 0.30101. Now that we should evaluate without tables log 16. Bring out log 16. We have log of 16. Equate it to a particular value of exponent of log 2, and we have the same value with 16. First of all, you know that 16 is 2 times 2, 4 times 2, 8 times 2, 16. That means 2 exponent 4 is 16. You are not making a mistake if you should equate log 16 to log 2 exponent 4, because 2 exponent 4 is the same thing as 16. Flashback, log to the base of any number of x exponent y is the same thing as y log of that same base of x. Bearing this third logarithm in your mind, you find out that log to any base of 2 exponent 4 is same thing as log to any base of 2 exponent 4 has the same value of 4 log of that same base of 2. We have applied the third law of logarithms here. If that is the case, remember they gave us that the value of log of 2 to 0.30101. What we're going to do here is to substitute, exchange log of 2 with 0.30101. When you do that, you're going to discover that 4 log 2 will now be equal to 4 times the value that has been given for log of 2, which is 0.30101. Use your calculator. You have 4 times 0.30101. It's given me 1.20404. And that has brought us to the end of that question. Question number 2 says we should evaluate without tables 3 log 2 plus log 20 minus log 1.6. There's one thing I will tell you before I go into solving this. I want to tell you that whenever you see a logarithm and there is no indication of base, assume that that log is on base 10. So these logs, as long as they have no basis, they are on base 10. We are going to change this to an index form, applying the third law of logarithms. And when we do that, this becomes log of 2 exponent 3. Bring that plus log 20 minus log 1.6. 2 exponent 3 means times 2 times 2. That is 8. So in this place we have log of 8 plus log of 20 minus log of 1.6. Log 8 plus log 20 means take down one log, 8 times 20. Because of this minus, we'll be dividing this by 1.6. This is further simplified to 8 times 20 will give you 160. So we are going to have log of 160 now divided by 1.6. 160 divided by 1.6 will give you 100. So I'm going to have log of 100. Remember, I told you, as far as there are no bases attached to these logs from the onset, they are in base 10. So this final term we got now is determined as log to base 10 of 100. And this is the same thing as log to base 10 of 10 exponent 2. What the meaning of this is 2. Because if you go to the thing I added as the fourth law of indices after the third, it explains to you that the value of the logarithm of a number to the base of the number is 1. The logarithm of a number to the base of the number is 1. So from here now, let's simplify further so that you exactly know why I got the 2 arrows here. The meaning of this is 2 log 10 base 10, applying the third law of indices. Assuming log of 2 to base 10, as there is no base attached, is 0.3010. Log of 3 to base 10 is 0.4771, and log of 7 to base 10 is 0.8451. You are asked to evaluate log 42 without using tables. In this case, what we're going to do is this. Try to break down 42 to factors of 2, 3, and 7. Mathematically, if you try to multiply 2 to 3 and to 7, you will get 42. 2 times 3 times 7 is 42. Now you are going to rewrite log of 42 to be log of 7 times 3 times 2. They have the same value because 7 times 3 times 2 is 42. Now, flash your memory back to logarithm law number 1. In logarithm law number 1, you discover that the meaning of log of 7 times 3 times 2 is the same thing as log of 7 plus log of 3 plus log of 2. The values of log of 7, log of 3, and log of 2 has been given in the question. Just pick those values and add them together. Log of 7 was given to be 0.8451. So write 0.8451 plus log of 3 has been given to be 0.4771. We have 0.4771 plus log of 2 has been given to be 0.3010. So we have 0.3010. Add them together. 1 plus 1 is 2 plus 0 is 2. 5 plus 7 is going to give you 12 plus 1 will give you 13. Write 3 raised 1. 1 plus 7 is 8. 8 plus 4 is 12. Plus 0 remains 12. Write 2 raised 1. 1 plus 8 is 9. Plus 4 is 13. Plus 3 is 16. Write 6 and raise 1. Point. 1 plus 0 plus 0 plus 0 will give you 1. That means the answer to that question becomes 1.6232. Question number 4. And it said that we should simplify 2 minus 2 log 5. Whenever this kind of thing is given to you and there is no base attached to the log, know it that that log is in base 10. Very, very important. 2 in logarithm to base 10 means log of 10 to base 10 squared. That's what it means. Because if you want to evaluate this, it's going to give you 2 log 10 base 10. That is applying the third law of logarithms. So the value of 2 in logarithm is log of 10 squared to base 10. Now, we have used this to substitute 2. Then we now have minus 2 log 5. What this means, applying or respecting the same third law of logarithm is, we're going to have log of 10. Of course, you know that this is 100. 10 squared is 100. Minus, the meaning of this, respecting the third law of logarithm, is log to base 10 of 5 squared. That's the meaning of this. If that is the case, we have what this means, or let's simplify this. You know that this means 5 squared, and 5 squared is 25. So I'm going to have log of 100 to base 10 minus log of 25 instead of 5 squared to base 10. Applying the second law of logarithms, this will boil down to having a singular log 100 because of this minus divided by 25. 10 divided by 25 is 4. That means our grand finale becomes log of 4. Number 5 says simplify 3 all over 4 log 16. The meaning of this, respecting the third law of logarithms, is log of 16 exponent 3 all over 4. That's the meaning of this. 16 exponent 3 all over 4 in indices means the 4th root of 16 exponent 3. I repeat, the meaning of 16 exponent 3 all over 4 in indices is the 4th root of 16 exponent 3. That means this means log of the 4th root of 16 exponent 3. What is the meaning of 4th root of a number? That number that will multiply itself 4 times to get the number is the 4th root of the number. In this case, the number that will multiply itself 4 times to get 16 is 2, because 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. Now we are going to have that the 4th root of 16 cube will mean 2 cube. because the fourth root of 16 is 2. So that becomes that this will now be log of 2 exponent 3. 2 exponent 3 means 2 times 2 times 2. And 2 times 2 is 4, 4 times 2 is 8. That means the value of this is also log of 8. If you don't want the answer to be in this form, you can go straight and say that this is equal to applying the third law of logarithm. You find that this will become 3 log 2. So either this or this is the answer to that question. Question 6 says, assuming log of x to the 10 is equal to 3, find the value of x. I want to tell you that if you can recall what I gave you as an assumed fourth law of logarithms. You know, I told you that the log of a number to its base is 1. For instance, that the log of 2 to base 2 is 1. The log of 3 to base 3 is 1. The log of u to base u is also 1. So if you have that in mind, that means that from here now, 2, this 2, which is the base, exponent 1, which 2 base 2 is its value, is the same thing as 2, which the log expresses, because 2 exponent 1 is equal to 2. This idea here now, the idea revolving here, take it to this. In this case, 2 is represented by 10. 1 is represented by 3. And this x is represented by 2. If 2 went to the exponent of 1 to get 2, that means 10 going to the exponent of 3 will give x. That means here now we have that log of 10 exponent 3 is x. You can remove this log, we don't need it. This is showing you that 10 exponent 3, which is 10 times 10 times 10, and 10 times 10 times 10 is 1000. That means that 1000 is the value of x. Question number 7 says, if 2 log to base x of 27 all over 8 is equal to 6, you find the value of x. If you look into this and if you try to apply the third law of logarithm, you find out that this means log to base x of 27 all over 8 squared, and it's equal to 6. Now, if you also apply what I gave you as an assumed fourth law of logarithms, you discover that x raised to the exponent of 6, which is in this side of the equation, is going to give you 27 squared all over 8 squared. Remember, what this means if you remove bracket is 27 squared divided by 8 squared. I want you to multiply out this using a calculator. 27 times 27 giving me 729. So we have that x exponent 6 is equal to 729 all over 8 squared is 64. So all over 64. Now you have an exponent in the left hand side with a base x. Try to convert what you have on the right hand side of the equation in such a way that we have the exponent of 6. What do I mean? Find a number that if it multiplies itself 6 times, you will get 729. And another number that if you multiply it 6 times, you will get 64. I'm looking at 3 for 729 and 2 for 64. Let's try it. 3 times 3, that is 2, times 3, 3 times 3, 4 times 3, 5 times 3, 6 times is equal to 729. That means in the numerator we are going to have, first of all, write down x exponent 6 is equal to 3 exponent 6. Now divided by, let's try 2 for 64. 2 times 2 is 2 times 2, 3 times 2, 4 times 2, 5 times 2, 6 times is 64. That means here we have 2 exponent 6. In this case, what this means is bring down x exponent 6 is equal to 3 all over 2 exponent 6. That's the meaning of this. Now that you have the exponents, remember in our previous practices, we'll be having the same basis and we have been equating the exponents. In this case, we are having the exponents. That means we will drop the exponents and equate the basis. Now you then have that x is equal to 3 all over 2. And 3 all over 2 in mixed fraction form becomes 1 whole number 1 all over 2. And that gives you the answer to that question. Question number 8 says, simplify log root 5 all over log 5. The first thing you do here is you're going to change the square root of 5 into an index form. And in so doing, you're going to have that log root 5 will now become log 5 exponent 1 all over 2. This is the index way to write the square root of 5. Bring down the denominator, log 5. If you look close now, you discover that if you apply the third law of logarithms, log 5 exponent half will now become half log 5. Bring down the denominator, log 5. As you have this now, you can cancel log 5 up and down. I'll be left with 1 all over 2 as the answer to the question. Question number 9 says, simplify log 8 minus log 4 divided by log 4 minus log 2. What you do here is this. You try to change all these figures to a particular log, as in descending them to their factors. And the factors that is going to work here is descending them to their factor of 2. You know that 8 is 2 exponent 3. 4 is 2 exponent 2. Same thing, 4 is 2 exponent 2. And 2 is 2 exponent 1. So we are going to reduce them to the basis of 2. What do I mean by that? Log 8 becomes log of 2 exponent 3, because 2 exponent 3 is the same thing as 8. Now minus 4 becomes, log 4 becomes log of 2 exponent 2, because 2 exponent 2 is 4. Divided by log of 4 is, will now become log 2 exponent 2, then minus log of 2 remains log of 2 exponent 1, if you like. What this means is 3 log 2, applying the third law of logarithms, minus this will now become 2 log 2, divided by this will be 2 log 2 minus, this will be 1 log 2. 3 log 2 minus 2 log 2. It's just like saying 3x minus 2x. You'll be left with 1 log 2. So in the numerator you have log 2. Now divided by 2 log 2 minus 1 log 2. It's just like saying 2x minus x. Here you will also be left with log 2. So we have log 2. Log 2 divided by log 2 will give you 1. That means 1 becomes the answer to that question. This is the 10th question. And that question says we should evaluate log of 8 divided by log of 4. What this means is log of 8 over log of 4. All over log of 4. As usual, try to dissect 4 and 8 to have a particular base and an exponent. You and I know that 8 is 2 times 2 times 2. That means 2 exponent 3. Whereas 4 is 2 times 2. That means 2 exponent 2. Write it in that form. Log 8 becomes log of 2 exponent 3. Whereas log of 4 becomes log of 2 exponent 2. In practice, and obeying the third law of logarithms, log of 2 exponent 3 is the same thing as 3 log 2 divided by log of 2 exponent 2 is certain as 2 log 2. You now have 2 log 2. At this juncture, you can do away with log 2 and you are left with 3 all over 2. And 3 all over 2 in mixed fraction form is 1 whole number 1 all over 2. And that is the answer to that question. This is question number 11. It says we should rewrite log x minus log y is equal to log z and make x the subject of the formula. If you look at this expression, you discover that if you apply the second law of logarithms, log x minus log y will become log x all over y. Second law of logarithms. From here you get this. From here you can also get this. Then it's equal to log z. After this, since you have log x all over y is equal to the same log of z, you can remove log. Just like having 2 times x is equal to 2 times y. You are free to remove the 2 that is common in both sides of the equation and equate the things that follows the 2. That will now give us x all over y is now equal to z. The question said we should make x the subject of the formula. So let's write z as a fraction. We are going to have x all over y is now equal to z all over 1. At this juncture, if you cross multiply, discover you have x times 1, which is x, will now be equal to z times y, which is yz or zy. And that has brought us to the end of that question. Question number 12 says we should rewrite log x plus 2 log y equals to 3. We are going to change 2 log y respecting the third law of logarithms. After which, we will change log x plus whatever we get as the value of 2 log y respecting the first law of logarithms. Let's first of all change 2 log y. So we're going to have log of x plus 2 log y respecting the third law of logarithms means log of y exponent 2. Everything is equal to 3. Now, log x plus log y exponent 2. If you respect the first law of logarithms, discover that the meaning of this is log of x times y squared. This means this, and this means this in the first law of logarithms, and is equal to 3. 3. First of all, I had told you that whenever you are dealing with log and there are no base attached to them, they are in base 10. This 3 has the value of log of 1000 to base 10. I want to explain that. Log of 1000 to base 10 means log of 10 exponent 3. You know that 1000 is 10 exponent 3. You know that. 10 times 10 is 100. 100 times 10 is 1000. That is why 10 exponent 3 means 1000. In this case, if you should apply the third law of logarithms, you discover that log of 10 exponent 3 to base 10 is the same thing as 3 log 10 to base 10. 3 log 10 to base 10. The log of any number, if you still could remember what I told you, that should be an assumed fourth law of logarithms. The log of any number to the base of the number is 1. The log of you watching me to your base is 1, if you can be brought to the whiteboard. That means that log of 10 to base 10 is 1, and what you have here now is 3 times 1, which is 3. Have you seen why I told you that 3 has the value of log of 1000 to base 10? So we are going to exchange 3 to log of 1000 to base 10. We are not going to write base 10 because it's all the scenario. There is no attachment of base 10, but we know that they are on base 10. So we are going to have log of x y squared is equal to log of 1000. You can remove log and remove log, just like saying b times x y squared is equal to b times 1000. You are free to remove the b, which is common in both sides of the equation. We are now having x y squared is equal to 1000 to be the answer to the question. Had it been that the question went ahead and told you to make any of these x or y the subject formula, you continue from here to make any of them the subject of the formula. But now the question is silent in that area. So the answer remains x y squared is equal to 1000. Question number 13 says, if log x minus log bracket opens 2x minus 1 bracket closes is equal to 1, that we should find x. Don't worry. They will keep on telling us to find x. They will keep losing x and keep giving us the assignment to find x. We'll keep finding x. If they cannot pay us here for finding x for them, we'll get to heaven. God will pay us. So let's find x for them here. So in this case now, let's apply the second law of logarithms so as to simplify this bogus thing. Log x minus log bracket 2x minus 1 means, respecting the second law of logarithms, log of x divided by 2x minus 1. and it's going to be equal to 1. 1 means log of a number to the base of the number. In this case, there is no base attached to the logs. That means they are on base 10. That will give me the attorney to tell you that 1 means log of 10 to base 10. So I'm changing 1 to become log of 10 to base 10. So I'm going to have log of x all over 2x minus 1 is now equal to log of 10. Log times this, remove log, it is not needed. Equate x all over 2x minus 1 is equal to 10. So I'm going to have x all over 2x minus 1 is equal to 10. We can write 10 in fraction form to be 10 over 1. If you cross multiply here, you find out you have x times 1, which is x, will now be equal to 10 times 2x minus 1. 10 into 2x minus 1. Remove this bracket. X is left in the left-hand side of the equation. 10 times 2x will give you 20x. 10 times minus 1 will give you minus 10. Collect like terms. You are to move this 20x to the left-hand side of the equation to meet its counterpart, x. That will leave you with x minus 20x. Remember, when positive 20x leaves the right-hand side of the equation and crosses the sign of equality, its gender will change. And the gender is, it will change from positive to negative. That's why we now have x minus 20x. It will now be equal to minus 10. X minus 20x will leave you with minus 19x. And it's equal to minus 10. Divide both sides by minus 19. So as you have only x left in the left-hand side of the equation. When you do so, you'll be left with only x here after you have divided minus 19x by minus 19. And it's going to give you minus 10 divided by minus 19 in the right-hand side of the equation. X will now become minus, we cancel minus, you'll be left with plus 10 all over 19. If you like, you can use a calculator and find this value in decimal form. 10 divided by 19 is giving me 0.5263. This is the answer to that question. Evaluate. Bracket opens 2 exponent x, bracket closes exponent 2, minus 3, bracket opens 2 exponent x, bracket closes, plus 2 is equal to 0. This is the type of questions you get in your external examinations. The truth is that this expression, there is no formula obtainable anywhere to decode it. What you do is you try to shift it from its nature to the nature of an expression that has a formula. And that expression that has a formula you should change it to should be quadratic expression. That is one thing you must do to change this expression into a quadratic expression. And that is that all the things you have inside the bracket which are alike, substitute them to any letter you like. Inside this bracket you have 2 exponent x. Inside this other one you also have 2 exponent x. Substitute them to any letter you want in the alphabet. Let's take x. Use x to substitute 2 exponent x in here and 2 exponent x here. 2 exponent x becomes x. Bring down the square. You have minus, bring down 3. 2 exponent x will be x. Bring down plus 2 is equal to 0. You cannot see that this expression has been changed to a quadratic expression and the value are still the same thing. Now factorize this for you to be able to find the value of x. In factorizing a quadratic expression, first of all create 2 brackets in this form. X squared means x times x. Split the 2x that multiply themselves to get x squared in the beginning of the 2 brackets that you created. After that, find 2 numbers that have the product of 2 and sum of minus 3. 2 numbers that if you multiply them together you get plus 2. If you add them together you get minus 3. Minus 2 and minus 1 satisfies it because minus 2 times minus 1 will give you plus 2. Minus 2 plus minus 1 will give you minus 3. So this satisfies that. If you multiply add this bracket, you get back this expression. I know you know how to do it. This is going to be equal to 0. We're bringing down equal to 0. If 2 things are multiplying themselves together to get 0, one of those things must be 0. And it is based on this principle that we can find the value of x now. X minus 2, the one you have that bracket is 0, or x minus 1 is 0. If 2 of them must multiply themselves together to get 0, one of them must be 0. In this case, if x minus 2 is 0, that means x is equal to 2. Or if x minus 1 is 0, that means x is equal to 1. So x is either 2 or 1 if the answer to that expression. Question number 15 says evaluate 2 in a bracket exponent 2x minus 10 bracket opens 2 exponent x bracket closes plus 16 to 0. Just like question number 14 that we just concluded, there is no formula that could apply to it directly like this at this level. Try to change it to an expression that has a formula that can be applicable, and that expression is quadratic. Before you change it to quadratic, first of all rearrange this. 2 exponent 2x is something as 2 exponent x2, because already in this other bracket you have 2 exponent x. So arrange this in such a way that the x will come before the 2, so that when you are substituting what you have in common in the bracket, it will be clearer and not confusing to you. So the expression becomes 2 exponent x bracket closes exponent 2. That's the meaning of this. Minus 10 into 2 exponent x, the one you have here, plus 16 is now equal to 0. Choose any letter to substitute the values which are the same thing that you have inside the bracket. In this case, let's use y. Use y to substitute the things you have inside the bracket. You are going to have the expression to be y squared minus 10y plus 16 is equal to 0. This is now a quadratic expression. So factorize this quadratic equation. In factorization, you provide two brackets in this form. Y squared means y times y. Split the two y that multiply themselves together to get y squared into the first space or the initial space of the two brackets you provided, just as I have done. Find two numbers that have the product of 16 plus 16 and sum of minus 10. Two numbers that if you multiply them together you get plus 16. If you add them together you get minus 10. I'm looking at 8 and 2. 8 and 2. Minus 8 times minus 2 will give you plus 16. At the same time, minus 8 plus minus 2 will give you minus 10. So we are correct. Remember, this is equal to 0. If two things must multiply themselves together to get 0, one of those things must be 0. And based on this principle, we can find the value of our unknown, which is y. If y minus 8 times y minus 2 is equal to 0, that means either y minus 8 is equal to 0 or y minus 2 is equal to 0. In the case of y minus 8 is equal to 0, y will be equal to 8. Moving minus 8 from the left hand side of the equation to the right hand side, you get plus 8. And if you add plus 8 to 0, you get 8. Or, in this case, y will be equal to 2. Taking minus 2 from the left hand side of the equation to the right hand side, you change to plus 2. And if you add plus 2 to 0, it will give you 2. So the value of y in that expression becomes either 8 or 2. I would like us to use this question number 16 to close our discussion on indices and logarithms. In this case, the question is unique. We are asked to evaluate log to base 2 of 6 using tables. Remember, we've been evaluating without using tables. Pay attention. When you are given this, try to create an equation with this. Creating an equation is equate this to a letter and start from there. That means you write that let the expression given to you, log to base 2 of 6, be equal to any letter. Let's use x. If log to base 2 of 6 is x, respecting the principles and condiments in logarithms, the ideas, technology in logarithms, it means that 2 exponent x is equal to 6. At this juncture, it's like you are running away from the logarithms. Introduce back the logarithms. You will now have that log 2x, log to any given base 2x is equal to log to the same base of 6. Now that you don't have any base attached, remember I told you they are in base 10. Log to base 10 of 2x means x times log to base 10 of 2. And it's going to be equal to log to base 10 of 6. If you want to have only x left in the left hand side of the equation, that means you have to divide both sides of the equation by log 2. When you do that, you'll be left with only x in the left hand side of the equation, and it's going to be equal to log of 6 to base 10 divided by log to the extent of 2. Now, apply the use of your tables. Get your 4-figure table. Open to Logarithm of numbers. You can find Logarithm of numbers in page 2 through page 3 of your 4-figure table. I know you know how to use the 4-figure table. You must have been taught from SS1 and SS2, or go to our DVDs for SS1 and SS2. You'll be taught how to use the 4-figure table. For adventure you don't know. Number 6. 6 is 1 digit. That means whatever you get from the logarithm table will be 0 points. You cannot take 6. That means I'm going to find 67, 7, 8, 2. It's not going to be divided by the log of 2. 2 is 1 digit. So whatever you get from each logarithm will be 0 points. You cannot find 2 in the log table, but you can find 20. So find 20 under 0. 20 under 0 is giving me 3010. Now divide out to get a grand finale. Just use a calculator. 0.7782 divided by 0.3010 is giving me 2.58538. I want to round it to, let's